Okay, this is one other thing. It was just one more document that was in our notes for Unit 1 that we didn't officially open and look at, but the concepts in here have been talked about in class, at least except for the symmetry, which is the question you get on the test about symmetry is mainly just looking at a picture and telling me if it has a specific type of symmetry, so it's not that bad. So remember, an equation in two variables, like x and y, is a statement in which two expressions involving x and y are equal. The solution, remember, to these types of equations were ordered pairs, so things like x comma y. So if we have something like 2x plus 3y equals 6, notice that this is an equation that has both x and y in it to the first power, so it's linear. And for us, now it doesn't have to always be linear, but for us this is the one we've been familiar with so far. Anything that works here and makes this true is going to have to be an ordered pair. We can always check to see if a solution is true by plugging it in to see if the left side equals the right side. We talked about this in class, but just to make sure you remember, we talked about graphing using slope-intercept mode, which was y equals mx plus b. We also talked about graphing by finding the intercepts. If you're not sure what to do, or if you're not dealing with a linear equation, one way to find a graph is to just make a table of values, which is an XY chart, pick some values for x, so -2 to 2, you plug them into whatever equation they give you, you find the y's, and then you plot the ordered pairs. So that's just in case you're just encountering a graph you don't really know how to attack. Intercepts, which we've already talked about, are points in which the graph crosses or touches either the x or the y axis. So the x-axis intercept is the x-intercept, and it always looks like this, a number of some kind and then 0. So that's an x-intercept. A y-intercept always looks like 0 and then a number. So that's how you know which one you're dealing with. To find, and we've done this in class too, so to find intercepts, remember, if you want x, you plug in 0 for y. If you want y, you plug in 0 for x. And your answer should be written as an ordered pair. Okay, so that gets us to the new topic, the one I wanted to show you. Now, we're not going to make you do this test algebraically yet. When we get to functions again later on, we talk about functions being even or odd, and that has to do with two of the symmetries we're looking at right now. I'm not going to tell you which ones, but when we get to that, we will need to do a test for symmetry because we'll just be looking at an equation and they'll be like, what kind of symmetry does this have? So for us now, we really just need to understand what the symmetries are. So if you want to have symmetry with respect to the x-axis, that's this first one right here. Sorry, it won't let me highlight it. So this one right here is with respect to the x-axis. Notice that as you look at the x-axis, there are mirror images of each point in the pink line. There's a mirror image down here on the blue line. So notice that each x is staying consistent, but the y went from being positive to negative. That's where the mirroring happens. So they flip it down, essentially. So that's what x-axis symmetry looks like. If I take that same pink line and I flip it across the y-axis, notice that this folds a different way. This folds over this way. So my mirror images are, my y's are both now the same height. This is the same height that I was forever, but my x went from being positive to negative. So notice that's how you get that reflection. And then origin symmetry means you do a double flip. So notice this graph got flipped over and then upside down. So it went over to the y-axis and then down over the x-axis. If you could draw another little halfway step somewhere in here. That's where it was in the middle. So a double flip means not only did your x change sign, but so did your y. So that's what we mean by origin symmetry. So on your test, you'll be given just a picture of a graph, and it will look something like one of these, and it'll say which type of symmetry does it have, and it'll have a choice for you to write x-axis, y-axis, origin, or none, because it is possible for a graph to have none of these. For example, a line that doesn't go through the origin. If you talk about this, this line right here, this has no symmetry. Okay, first of all, it doesn't fold across the y-axis because it would need to be up For that to be a match, you'd have to make like a V shape here. It doesn't fold over the x-axis and match up. There's not even a graph down there. And it's definitely not a double flip, because if we take this piece right here and try to double flip it, it would be a V up here, and then it would be way down here when you flip on this direction. So just because we discuss these symmetries does not mean every equation has them. So just be aware of that. So these are just special reflections across x-axis, y-axis, and both. And that is all there is to symmetry. So that ends that section. It was a pretty short section. It was really just summarizing some key things and introducing the idea of symmetry.